Okay, so for starters, we're going to look at the equation that we used in the pendulum lab, and we're going to compare it to the equation we're going to use in the spring lab or Hooke's Law lab. The equation for a pendulum is this, square root of L over G. For a spring, it's the square root of M over K. K is a Hooke's Law constant, and we're going to calculate that Hooke's Law constant in lab today, and we're going to be able to calculate the period of a spring. But hopefully you can see that the equations are basically the same equation, just a couple of different variables. Your data table has this, these columns. This is the data that you're going to collect. The mass that we're going to attach to the bottom of our spring is mass. It needs to be in kilograms. So you're going to remember, if you have 100 grams, you're going to divide that by 1,000. It would be 0.1 kilograms. Convert it to newtons, multiplying by 10. The stretch of our spring needs to be measured in meters, not centimeters. This first column for period is your handheld, so you're just going to use your phone or a stopwatch or watch or whatever and calculate the period, and I'll show you that when we get back to the lab. This column is your calculated period, and that's the period that you're going to find by using that equation, calculation. The last column is your percent error. That's going to be the difference between these two divided by your calculated column. So, difference between your handheld period and your calculated period divided by the accepted value, which is going to be our calculated period. Okay? So how do we find that K value so that we can complete that equation? And it says this on the bottom of your lab. We're going to graph the force, has to be in newtons, versus the stretch, which is in meters. Okay? Now, the graph that you get is going to be fairly linear, and you're going to do two different springs, which is why your data table was doubled. And once you get the data plotted on your graph for the two different data sets, you're going to do a linear fit, and the slope of this line, the change in the force, the rise, over the change in the stretch, the run, is your K value. And that's called Hooke's Law constant. Okay? So you need to graph your data from your data table before you can find the slope. In order to find the slope, before you can actually do your calculated column for period, because you need the K value in order to put that into your equation. Okay? So let's leave this, and we'll go back to the lab, and I'll show you the equipment, and then I'll let you go to work. So let's come on back here.